Hello, class. Today we're going to be multiplying decimals and whole numbers using the standard algorithm. And in a previous video, we have used with the model, which the model is great to understand the concept of the repeated addition within the multiplication and being able to relate the multiplying of decimals to multiplying of whole numbers. But that is not a method that is feasible for reality, as to the point that it only really works with very small multiplications of the ones, the tenths, and the hundredths. When we work with much smaller numbers, like say the 10,000ths, 100,000ths, or even if I look at 1,000 or 10,000 or 100,000, drawing all those models out would take you a very long time. So one of the things that we've come up with to use is what we call the standard algorithm, the regular way most people do their multiplication of decimals. But before I go into those details, I want you to pause the video, put in your notebook your complete heading, which includes your full name, first and last name, the date, mathematics, your period number, and the title of this lesson, multiplying decimals and whole numbers using the standard algorithm. Pause the video now and put that in your notebooks. So now that we have that, right, let's look at our question. We have 2 3/10 times 4 51/100. So when I multiply that, we're going to put that in our vertical way. And here we don't have to put it by place value, because it is a simple fact that we are going to multiply a different way. So here we have the multiplication with the decimals. And people are like, wait, how do you multiply? There's decimals. Well, in reality is you're multiplying it the same way you would as if there wasn't any decimals. So I would write it on the side the same way that you would have multiplied, right? So here doesn't have our decimals, but in our red, we do have a decimals. We're going to multiply just using the green part first. And we would multiply the normal standard way. 1 times 3 is 3. 1 times 2 is 2. Then on the next line, because this 5 is really a 50, I'm going to put my place value holder of an x and do 5 times 3 is 15. So I bring down the 5, I carry the 1. 5 times 2 is 10, plus the 1 is 11. Since there's nothing else I need to multiply, I'm just going to write the 11 down. Then I multiply the 4, just like I normally would. I start the second line with 2 x's, the third line with 2 x's. 4 times 3 is 12, so I bring down the 2 and I carry the 1. 4 times 2 is 8, plus 1 is 9. Now that I multiplied all numbers, I'm going to add them. So 3 plus x gives me 3. 2 plus 5 gives me 7. 7 plus x gives me 7. 1 plus 2 gives me 3. 1 plus 9 gives me 10. And since there's nothing else that I need to add, I'm just going to write the 10 down. Now that I have that, I'm going to rewrite the solution over here, right? That's just my solution. Now, that is the answer in digit-wise to this, but now I got to put the decimals in. So I'm going to draw 2 little arrows on the side of each number. And I'm going to write how many decimals, actual decimal numbers, are included in here. So I look at this number. The 2 is not a decimal. That's a whole number. So I can't, and I only have 1. So I'm going to write 1. In the 4 and 51/100, I have 1, 2. So that's 2. And I add these numbers together and I get 3. Since I have that, I then go to the very right of the digit and I'm going to count 3 loops. So my decimal is going to jump 3 times. So I'm going to have 1, 2, 3, because this number here is 3. How many decimal places? So when I look at this, I'm going to equal the 10. And then my decimal landed here, so I'm going to rewrite the decimal there and just copy the other numbers. So my solution to this one is 10 and 373 thousandths. So when I'm multiplying decimals, I actually do the multiplication without the decimals. And then I look at my factors and count how many decimal places there are together, and I move my decimal over that many spaces. It gets a little confusing, but after a little bit of practice, this will become the second nature, that you multiply without decimals, then you count the number of decimal places of the factors in your original number, and then you just move the decimals over. Let's do another problem for an example. Here we have 11 and 2/10 times 4 and 57 hundredths. So again, I'm going to write those numbers vertically. I'm going to write it with the decimals. Why? Because I like to know and see my stuff visually. Then I'm going to rewrite it without the decimals. And I'm going to then multiply. We're using just the whole numbers, not even looking at the decimals. I'll look at the decimals at the very end. So I have 7 times 2 is 14. I bring down the 4, carry the 1. 7 times 1 is 7, plus 1 is 8. 7 times 1 is 7. Then I go to the next number. Since this is 5 is really a 50, I'm putting one placeholder down. So I could just do 5 times 2 is 10. Bring down the 0, carry the 1. 5 times 1 is 5, plus the 1 is 6. And then 5 times 1 is 5. Then this 4 is really 400, so I need 2 place value holders. 4 times 2 is 8. 4 times 1 is 4. And then 4 times 1 is 4. And then I'm just going to re-add these up. 4 plus x gives me 4. 8 plus 0 is 8, plus x is 8. 7 plus 6 is 13. 13 plus 8 is 21. So I bring down the 1, carry the 2. 2 plus 5 is 7. 7 plus 4 is 11. So I bring down the 1, carry the 1. 1 plus 4 is 5. So when I multiply these numbers out, I know that I have 5, 1, 1, 8, 4. Now that I had that, I can go and count how many decimal places. So I write my 2 little arrows and I count. This has 1 decimal place. This one ends up having 2. So 1 plus 2 gives me 3. So I know I'm moving that decimal 3 times. I start at the far right and I go over 1, 2, 3. And my decimal lands here. So I know that my solution is going to equal 5, 1, decimal, 1, 8, 4. So my solution is 51 and 184 thousandths. So again, I multiply as if there was no decimals, and then I count the decimal places in my original number, and I just move that decimal that many times. I want you to pause this video now and put this question, all of our work, and our solution in our notebooks. And if you haven't done so, also make sure you have the first example in your notebooks. All right, now that we've gone over 2, I want you to try 2 on your own. I want you to show all of your work, and I want you to solve this using the standard algorithm method. If you choose to use another method, you may to check your work, but I want to see the standard algorithm in your notebooks. So I want you to do 3 and 2/10 times 1 and 8/10. And the second problem is 4 and 1/100 times 4 and 27/100. So don't forget to show all of your work. If you need to watch either this example or this example again, you may. You may watch this video as many times as you need to. Okay, but make sure you show all of your work or all the work that you think you're supposed to be doing for these questions.